there is always something lowering my volume. So system sound. Okay, settings up. Just decided to crash. Alright, so system sound, more sound settings. Oh yeah, let's crank it up at maximum power. And that's it. Alright, sound should be good enough. And gonna open the project so we can get started. Let's go. Let's go. Hey again. By the way, I wonder if you I don't know if you want to join on Discord and join the chat server, so you don't have to type. Let's see, I might. I don't know. Live stream might be on the live stream channel as well. I don't know if that would work. Oh, there's an update. So if I get into here, it should be live in both of them. Nice. If anyone wants to join. The permissions, private channel. Yeah, that should be alright. Not sure about the volume though. Anyway, let's go back on Tracy. So the last time it was working. I'm gonna zoom on the IDE. So we got some Tracy working, and the next step would be to get it integrated into Vulkan. Wait, no, I had, yeah, there was a PDF. So that was Tracy PDF, okay. So there should be GPU profiling. Okay. Well, memory profiling as well. That should be interesting. Memory profiling, memory usage graph. Okay. List of active allocations. So I just defined those. And it should be alright because the whole program is compiled at once. Let me quickly check. So everything is objects. So they are linked afterwards. The app itself, it is compiled as an object. Which, by the way, might not even be a sensible way to to lay down a project. But yeah, I'm just learning how to do modules. Let me move a few windows around. And done. Okay. So I guess I just defined the new operators here. And that should bring me auto pointer local variable return. That might be const. I cannot convert const void to, oh wait, why? Okay, why is it not const? Anyway, okay, that's it. Let's check if this is going to be actually called. That would be very nice to see what the heck is going on. I haven't been incredibly good at this so far. So what? Okay, so that's new. Why is it new? That's weird. Why are you newing? Why are you newing something on stack? Window context. Huh. That was unexpected. Default allocate bytes. But that's odd. Is it because of the constructor? Let's go check. Oh yeah, it's got plenty of stuff in the constructor, but create, but there's no allocation needed. That's super weird. What are you allocating for? Container proxy. What the heck is going on? I just opened the Pandora box. And more allocation. More allocation. What? Am I stuck in a loop? Construct in place. So this is allocating something. That's not a shared pointer. So what do we have here? We have the app base. Oh, okay, maybe it's one of this stuff. But there is no allocation, technically. There shouldn't be any. So there's a vector, but it's empty. Okay. Well, let's just keep going. So many allocations. I also put zone scope profiler within new delete just to see the cost of allocation as well. Well, the cost of each allocation, I'm not sure how much that would cost, but something that I really want to do is to go through the Zig philosophy of having allocators everywhere. But yeah, I'm not sure when is the right time to do that. Well, let's just see what happens if I run it. Okay, well, at least it's working. What? I didn't run. Okay. Wow. This is wild. By just not doing anything, it's doing a lot. Tiny allocations. This looks like a growing vector. Oh, it's a garbage collect. Oh, okay, makes sense. It is growing, and then... Ooh. With save points, so I can batch allocations. Then free those without any mallocs or freeze. Yeah, that's also my set to go. Yeah, there's definitely something bad in the garbage collect. It was fairly simple code anyway. I feel like this is kind of premature optimization, but yeah, it's also kind of easy to fix. Garbage collect. What are you doing? You are not delete, so we are placing into not delete. So this guy is growing. Mouse lifetime semantics makes the verifiability safe at compile time too, which is nice. Okay, yeah, this is very nice and sound, but last time I checked, C++ is somewhat cumbersome, but it's been why Unreal Engine does it a bit different and arguably nicer. Yeah, I guess one could easily implement its own stuff, which makes sense for a game. But at the same time, maybe you don't want to do it. So, understandably. Containers. Yeah, I have mixed feelings about containers. It's like the difference between the containers, the standard C++ library, and the language itself. I kind of like the language. I don't like the standard containers much. They're weird and yeah, not very nice, not complete, not. They're basic. Ranges make somehow a little bit more enjoyable, but still weird enough. Well, whatever. I'm not using that much anyway. So most of the code is dealing with the API. I think ESTL is appeals that have better allocators API. Yeah. Anyway. Let's go back to GPU. So we got memory profiling, which is nice. I don't know if it's going to catch all of the memory allocations, because this is going to catch only the C++ allocations. I wonder if I can overwrite malloc. Let's see. Of course I can, but well, maybe there's also something about it here. Memory pools. Yeah, something that I haven't done is passing an allocator into Vulkan functions. So I feel like I'm being lazy, but seriously, yeah, that's a bit too much though. That's why the whole thing collapses. So we need a language that forces you to do all of these things. But at the same time, it's also nice not to have to do it. So I don't know. So that's why I like not being able, so I can get things done faster. Sometimes you don't want to do things perfectly. You just want to get them to work. And at the end of the day, it makes sense for big corporations and for safety stuff. To go super safe, but to be honest, I just want to have fun. And for me, C++ is the most fun so far. Not that I have tried, like, not that I've done any in-depth, but I also don't want to do that. And there are so many languages, like, I don't know, there's a language for every letter in the alphabet. I think the last time that I checked, there was this VLang thing. And it was like, why? Why do we have another language? They're all very similar. And it crashed Chrome, I think. Okay, it's back. Yeah. Why would I pick this language, right? Simple, save, compiled. Yeah. They're all the same. It has annoyances. How is Carbon going? No, not that Carbon. Carbon lang. I wonder if it's if this is any interesting. Yeah, that would be nice to have this mixed as a nice transition. So you have all of your code and then you just change the compiler. Keep working and then you start to try a new flavor, see what you like, and yeah, slowly start transitioning. 2025, there's no update yet. Yeah, problem when it comes to context, but no reflection, mutable by default. Well, mutable by default. I mean, you can just make things const, right? Like it's just you not writing const. And I've started writing const like automatically, and then remove it whenever I see it doesn't fit. It's fine. I mean, it's one could say, why don't you remove this symbol? I never know what's the name of the symbol. And well, so yeah, why don't you just make it optional at that point? Reflection is said to be coming. Yeah. Let's see. Yeah, no build system. Well, CMake, it's the build system, so even that is. But what I find that nice is the lack of, not the build system, but the lack of package manager. I feel like package manager is doing somewhat of a lazy thing. Like, hey Goomba, I think like the package manager is doing the opposite of what it should be, like making things easier. It just makes things lazy. And I hate to see like hundreds of dependencies on You never see that in a C++ project, a C++ project. So everything is carefully thought, and you don't just start slipping in useless libraries, like one for coloring and one for I don't know, very. I'm making turtle crossing game in Python today. Oh, that's nice, Goomba. Have you started it already? Oh, by the way, I'm going very slow. Let me speed up a little. So GPU, how do I start it up? Vulkan, yeah. Go to Vulkan. Similar Vulkan, you should include, okay, Vulkan, Tracy Vulkan. So includes, go here. Yeah, I think that I've started doing some Rust at some point. I just had this. I wanted to do something in Vulkan, and what already stopped me? Not that I wasn't really motivated anyway. So I just wanted to make a little triangle, very quick, and then by the time I wasn't able to locate an actual Vulkan header, and then you find like 100 Vulkan libraries, and I was like, what? Which one is Vulkan? I just want the Vulkan, not like any wrapper. I can locate that in C++ and probably other libraries as well, other languages, like in what is the other language? Odin. I think in Odin you have the official Vulkan library. And yeah, that's just one. That is one Vulkan, and then you can have wrappers as many as you want, but that by the lack of an official one, it's kind of breaks my OCD. Okay, we got Tracy, Vulkan. So tracing Vulkan devices and queues is a bit more involved. In the Vulkan initialization macro, Tracy VK context. Okay. Returns an instance. Tracy VK context. Okay, I think we can do it. We can do it here. So we need a context object. VK Tracy. Nope. I just broke it. No. Why did I call it VK? It was Tracy VK context. Wrong order. Tracy VK context. Okay. And Tracy context. And it's a pointer, I guess. It's going to be null. And then Tracy VK context to initialize it. Let's see, where is a good point? So at this point, we have it already initialized. So we need to go to main. Init. Well, we don't really care what happens before initialization. So if we're in XR mode, we depend on XR, on VK. Well, so at this point, we should have everything in VK. Yeah, it should be in VK anyway. So I guess we can do a Tracy VK. No, wait. No, that's an instance. Trace. Oh, wait. Tracing. Vulkan devices. There's a macro. Okay, Tracy VK context. Wait. Okay, context. Naming. This is the function name. Okay. And it needs. So the physical device. Oh, wait. It doesn't have a physical device. What if instead, maybe a better place is to throw it in the Vulkan class instead. Could be. So I'm gonna move it here. Yeah, I'm gonna move it here. Then I need the header, so it doesn't need to stay here. The headers are not exported from the module. So do I need Tracy? Yep, maybe I need Tracy too. And also Tracy client. Is this the one? Yeah, VK Tracy client. And this is exported as public. So I guess I can remove it from here. Okay. Maybe I still need this. Cool. We have it now. On create. Find physical device. Physical device. Okay. Create a device. Enable features. By the way, there was something about features. Calibrated. Vulkan 1.2 context. Dynamic loading. Vulkan symbols. Okay. Yeah, I'm gonna do that after I locate a good place to do that. Create Vulkan objects. So this is also, this is called in two places, 1 and 2. Okay, so it's a good place to put the code because because the Vulkan, the instance in the VK module is also created from the XR module. So when XR creates Vulkan context, then it passes it over to the VK, so the VK can be still valid. Even though something is still split between the two, and maybe, yeah, maybe I should, I don't know, maybe I should try to move more of the Vulkan stuff into the VK module, because some of them still live here. And that's also why I have to do this kind of stuff. So the render path lives in XR, and sample count and swap chain count. And technically, one might not require to do any non-XR related calls from the XR class. But the design itself is a bit weird because XR requires Vulkan, so they're not very well separated. XR itself needs Vulkan. Okay, anyway, let's go back to our create Vulkan object. We got everything. No, not this. So that was Tracy VK context. So let's create the context. Now we have the physical device. Then we have the device. Then what is next? A queue. We have the queue. Ooh, a command buffer. Command buffer. Wait. The queue, and then the command buffer. What are these null pointers? I'm gonna give you the immediate. No, that's the pool. Okay, you don't need a pool, you need a command buffer. But we don't have any pools yet. So also I don't have any queue. So that's where we are getting the queue. So this is totally wrong place to put you in. Resettable command queue. The command buffer. Okay, we get that. I guess you now need command buffer that I could allocate it from the immediate one. See. PK allocate command buffers. There you go. Create command buffer. Okay. So this creates a command buffer from the ordinary pool. I don't think this is even used. Yeah, this isn't used anywhere. Create command buffer. Let's say command pool. Allocate command buffers. So the command, oh wait, but the command buffers are allocated, but they're never destroyed. Yeah, because they are reset. Okay, that makes sense. So they get reset. And I guess I should just use this function. Finally make it useful. This returns. Wait, does this return something? It probably returns the context. Calibrated. Okay. This guy. It's a static. Okay, it returns the Vulkan context. That is good. So this means Tracy context equals to this guy. And then we need Tracy command. That should be it. So this boy gonna have a VK command buffer. All for yourself. Tracy command, which is null. And that will be Tracy command buffer. Calibrated context, yeah, not now. So returns an instance, okay, an object with trucks and associated Vulkan queue cleanup is performed using VK destroy context. We are not gonna care about destroying, right? Because we can do that. Yeah, C++. I'm gonna let the OS clean up our mess. Physical device, logical, okay, blah 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 blah. Command must be in the initial state and be able to be reset. Yes, it is. Wait. Tracy VK context from Tracy VK what? Tracy what? Isn't it the same? It's literally the same. Oh, because it's already pointer. I hate it. Tracy VK context. Let's make it obvious. Okay, and also this isn't, I not like it. Tracy create VK context. And what are the command buffer. Okay, we don't have that, and we don't have these two, so it makes sense to null them. Okay, this makes much more sense. You may create multiple Vulkan contexts. Nope. The physical device, logical device, command buffer needs to be reset, and that is, yes, it's created to be resettable. To mark GPU zone, use the Tracy VK zone. Context, command buffer, and name. And color. Okay. That's it, right? Dynamic reloading Vulkan symbols. So calibrated context. In order to maintain synchronization between CPU and GPU time domains, you'll need to enable VKX calibrated timestamps device extension to retrieve the following functions pointer. Okay. And VK get calibrated timestamp. Do we even have that? Let's go and check. So that's going to be calibrated. Nope, we don't have that. No timestamp stuff. Okay, so that won't happen on the quest. Okay, so delegation. Okay, no problem. By using VK context host calibrated, you can make use of this feature. It only requires a function pointer to VK reset, in addition to the one required for. Okay, that's some advanced stuff. That's it. I don't need anything else. That's cool. Fibers. I've always wondered what fibers are. Fibers are lightweight threads, which are not under the operating system control and need to be manually scheduled by the application. As far as Tracy is concerned, multitasking primitives to enable fiber support. Okay, no, we don't need that. We're not using anyway. So now, how do I start setting up Tracy VK zone? Okay, so they're kind of coroutines. Yeah, coroutines. I can't even make up my head, wrap my head around it. I've seen there are plenty of talks about it. You know, there is the Aku conference. Yeah. So I had some of these talks in my playlist, and there are some coroutine. Okay, you don't coroutines. Yeah, there's plenty of coroutine stuff. Oh well, that is the only one. Okay, never mind. Order. One month ago. Okay, so there are some, I guess. Yeah, I mean, you really have to dive into it, and I think they're going to be useful at the higher level. So it's in my opinion, they are high level construct. If I think about Unity, then they're very good for the gameplay. I don't think lower level is going to be good with coroutines. It allows you to write single-threaded looking code but utilizing all your cores. Well, you could do that as well with no, actually, how can you do that? Like, it can't be single-threaded if you're using all of your cores. Yeah, that sounds more like a task-based concurrency. Well, you still like you're not spawning new threads, but more like using a thread pool. That would make sense. So now I just need a way to get the Tracy. So that is going to be a no, not color format. Tracy, how do I call it? So that's going to be Tracy Vulkan context and Tracy. Can I do that? Maybe it's a clash. And that will be const no accept, and return Tracy context. That's it. We got Tracy. Now back to the app. Or maybe you can do some tracing already here. So the create, I don't want to trace creation. Create swap chain. Timeline semaphores. Create command buffer. Create fence. Execute immediate. Well, we could execute immediate is just called at the initialization. So we want submit maybe. Yeah, of course you get different primitives, the same job done, but it's much more readable. Working on a custom async runtime with coroutines that will use custom allocators, so I can just bump allocate all my task coverage very cheaply. Oh, okay, that's sounds interesting. Yeah, I could actually give it a try with the chunks generation. That sounds like a suitable place to do some experiments. Is submit used? Okay, we don't have much usages of these functions. Okay, present. Yeah, we do have a usage for present. Present. This is Tracy zone. So let's begin with Tracy zone. Tracy C zone. Wait. Is it? How is it called? Oh, zone. Okay. My bad. Zone. Zone scoped. How is this defined? Zone named. And it's okay. Source location data. Oh, okay. There's a lot of stuff. I've implemented pipeline rendering mine trivially with coroutines, and most gameplay is thread as well. I have no dedicated threads. Lots of modern engines are moving to this direction. Not necessarily using coroutines though, but just task job system in general. Well, I had that in my old OpenGL engine. So it was, well, OpenGL already forced you to do that, and it was, I had the OpenGL context, and then everything was task based. Pretty nice. So you don't have to think about when things get scheduled. Now how to say it. Curtains are the nicest abstraction for that, in my opinion. Rust is actually the only language, as far as I'm aware, with truly zero cost coroutines. Well, when you're doing concurrency, there's really no zero cost. So concurrency, in my opinion, must be avoided at all cost. Only when it makes sense. Just do it. Like gameplay, for example, I don't think gameplay would work nice in a very linear way, and which is how most of the game engines are architected. You really don't want things to be out of order. Okay, so this is cool. Let's present. How can I make another scope? Let's also scope this. No, that's not present. This is weight semaphores. Okay, yeah, there's no runtime by default. Coroutines in Rust can be stack allocated and have no direction like vtable to invoke them. Oh. Very nice. Timeline acquire. Update and render. Begin and present. Then back to this place. We have the render, and where's update? Okay, we have update. We can break update down. We already have this broken down. Anything runtime is arguably less worth it. Yeah, I mean the hardware is it's very cheap. Sometimes I quite envy people working on a big fat GPUs because they can get more done. So there is present GQ present. Zone scoped, and this is present. Q present. Okay, so now where do I start the GPU profiling? Vulkan, Tracy VK collect GPU events. Oh, you also need, okay, Tracy VK zone. again. Welcome to Discord. Am I missing something? So it needs its own command. That's fine. Alternatively, image Tracy. Okay. Tracy vk collect. Okay, so they must be in recording state. Okay, so it is in recording state. So this is the beginning. Then we go to the render. So in render, we do the pipeline. Let's see all the VK commands. Begin render pass. Okay. Find the pipeline. Okay, so we have the copies here. So zone VK, is that how it works? Tracy VK zone. Okay. Tracy VK zone. Context, command buffer, and name. Okay. So the context is going to be VK Tracy, command buffer, stat guy, and we say copy buffers. Wait, what's Tracy? Why not const? Why not const? Okay, so no const allowed. And this can be const because it's just copied. Okay, should be happy now. Okay, now it's happy. Yeah, I know. I don't know. That's going to be everywhere, so it just doesn't make sense at that point. Const cast everywhere. So copy buffer, okay, we have the copy buffers, and then I don't know, should I put the barrier? Copy barrier. I was wrong. Has already been defined. Because it's not the scope. What? What does it? Don't know. I didn't think it was a scope thing. I need an example. And there's no example. I mean, I understand this is a scoped, but this were... Oh, okay. Okay, so it needs a beginning and end. Okay. So it's probably going to do some RIA stuff. And there you go. Then you get the barrier. Yeah, maybe I'm doing a bit too much, but right now I don't really have a lot to profile anyway. And I guess the rest is just the render. This is a quick trick. Give those objects a unique name within the macro. Seems like the author didn't do that. But maybe they're doing something at the destruction. So they have the command, they have this. So at the end of the zone, maybe they do something else. So that's why I don't know how it is implemented. Tracy cold stack. Yeah, they're also collecting other things. Anyway, I think should have enough. Connect. Chat. Can I have an auto start? Global thread rendering auto start limit. Did this start collecting before I even started? Yeah, probably. Whoops. What happened? It just died. Oh. Wait, what? Okay. Yeah, it will capture. I thought same, yeah. What did I do wrong? Allocate command buffers to an invalid command pool. Okay, that's why I was probably oh wait. Is this Tracy? Oh, come on. He just allocated the command buffer before creating the pool. It was just right here. Oh boy. Okay. Never mind. Never mind. You can fix that. Let's go back. Oh, waiting for connection. Too late. There we go. Okie dokie. Okay, that's enough data. Ooh, wait, semaphore is huge. Wait, semaphore is huge. Damn. Why it's so big? I kind of feel like it's not doing a proper in-flight frame. Yeah, there is likely. Where's the GPU stuff anyway? Where's GPU? Where don't see any GPU data. Huh. Well, this is interesting though. It's already very interesting. Acquire is as expected, but this is just nuts. Yeah, the whole timing is overwhelmed by this wait semaphores. Okay, that sounds like a good place to start with. Maybe doing something very, very wrong. And I guess this is what I will have a look next time. So for now, my time is run out, and I'll see you next time. We know what to do. Cool. I'll catch you later again. See you soon. Bye bye. Have a nice day.